We are getting ready to turn Split Horizon back on router 1. We're going to override that default that happens on a serial interface when you're running frame relay. And also I'm going to show you a very, very helpful command. It's not just for RIP, but it's really helpful to get over the slow convergence of RIP and force some routing updates. So some good stuff here. Let's go ahead and head back to router 1. And the command I want, I'm actually going on the interface itself, and I'm turning this on. And for those of you who have been doing this for a while, it can be really easy just to put no IP split in, but we're not doing it here. You're so used to turning Split Horizon off in some situations that here we're turning it on. So what you want, the command, is IP split. The full command is IP split horizon. And if we were running EIGRP, we could specify that and then an autonomous system number. Don't worry about that yet, or even what an autonomous system number is, because all we need right here is IP split horizon. Now, what I'm going to do is force a RIP update. And I will explain this command in just a moment. Let me go ahead and run it on all three routers here. I mentioned several times one thing that gets frustrating about RIP is its slow convergence. And even turning split there off, I'd have to wait a couple minutes for the routers to realize what was going on and the new updates to go out and come back in and get put in the tables. So instead of waiting, what I did is I forced an update with RIP by clearing the routing tables. And note the asterisk that I put there. Let me run clear IP route and then iOS help. And not a lot of options here, but you can, the main reason you're going to use this, I mean, I very rarely use these other options, so don't even concern yourself with those. What I would like to use this for is clear IP route asterisk, and what that does, it deletes all of your dynamically learned routes. Now your static routes and your connected routes, they're not going anywhere, but it will empty your routing table of all dynamically learned routes. So what happens then? Whichever routing protocol you're running, it's going to go ahead and start an update immediately because it's going, hey, I got no routes. It's like you just configured that particular protocol. You're not going to run this a lot with EIGRP and OSPF in your later studies because those protocols converge so quickly. But RIP, as we know, does not. So this is a great command, especially for lab environments, when you just want to go ahead and force an update instead of sitting there looking at your watch and wondering how long it's going to take RIP to catch up to you. So let's have a look at router 1's routing table right now, or the RIP table, and we see, the same routes we saw here before, and I'll go ahead and ping them. So we're good there. Let's head down to router 2. And look at that. We don't have any RIP routes. Therefore, there's no way in the world we're going to be able to ping 3333, right? So let's go ahead and try it. And those are just going to die out. So I'll go ahead and kill that ping. And that is Control-Shift-6, Control-Shift-6, that escape sequence. They tell you to type the escape sequence to abort the ping, but they don't tell you what it is. So I think I've mentioned it before, but I'll mention it again. Control-Shift-6 twice, just once right after the other. It can be a little awkward keystroke at first, I certainly grant you, but you will get used to it. It'll become second nature to you. And now let's have a look at router 3. And router 3 doesn't have any RIP routes any longer either. Why? Because now Split Horizon is in effect. We just enabled it. So router 2 is sending its ad for its loopback up to router 1. Router 1 gets it on serial 1/0, looks at the update, puts it in the table, and then that's it. It's not going to advertise it back out to router 3 because of the rule of Split Horizon. It learned about loopback 2, that particular network, on 172.12.123.1, and now that we enabled it, it cannot advertise that same route back out the interface. And the same thing's going on with router 3's loopback. So right now, neither spoke is learning about the other spoke's loopback because of Split Horizon. So if we wanted to go ahead and turn Split Horizon back off, it's just no IP split. I'm going to go ahead and do some clears. I probably just need to do that on 1, but I'm going to do it on all 3. And now we shouldn't see any changes here on router 1. We can see that. But now on 2 and 3, and there's 3 back because we turned split off. And we can ping it with no problem. We go to router 3. There's router 2's loop back again. We ping it again, and everything is beautiful. So again, that one default is important to remember with Split Horizon, is that if you're running it on, if you're running a serial interface and it's on a frame relay network, which is exactly what we have here, then Split Horizon is going to be off by default. It wasn't that way for a really long time, believe me, because the first thing you would type when you were configuring the interface was no IP split. But here, that gives you a great idea of what happens when Split Horizon is enabled. And you can see, as I mentioned when we were talking about that, how it can come back and bite you every once in a while. And here, it definitely would. So we're going to stop right there for a moment. When we come back, we're going to talk a little bit about that distance we saw. We're going to run some debugs as well on RIP, because I want you to see a debug of RIP and just see what a packet update looks like. And equal cost load sharing, all kinds of great RIP stuff coming up, and it's all coming up next.